Good afternoon, everyone. Thank you so much for joining us for another one of NextWaveSTEM's webinars. We are really excited to have you on the line. And today it's going to be a really cool experience because we're going to dive into a really tangible way in which emerging technologies are being used by students to make some really powerful global impacts. Um, my name is Desmond Martin. I am the program coordinator at NextWaveSTEM. That means I have the opportunity to speak with teachers, with educators and principals, administrators, all of our stakeholders, and share a little bit about what we do at NextWaveSTEM, train on our curricula, make sure that our teachers are prepared and have the tools that they need. Um, During the course of today's webinar, I should say, just as a little bit of ground rules, we are in webinar mode. That means that while you might be camera ready and ready to go and really ready to get vocal, we won't be able to see your face or hear your voice during the webinar. The upside to that, though, is that you're not completely voiceless. We do have the chat and the Q&A functionality turned on today for the webinar. So if you have any questions, if you have any comments, if you have something that you want to add, um, go ahead and jump in the chat and you can speak your mind completely freely. In that same vein, I'd also like to say that my colleague, Segundi Chagani, who is our school partnerships manager, she is also on the line um, as a moderator for our chats. That means that if something is said that I don't see that gets missed, we're going to make sure, Segundi is going to make sure that we get that information to me so we can answer your question or address that comment live on the air. Um, and Sugandhi is also going to be chiming in a little bit later as it relates to the ways in which NextWaveSTEM is going to be able to help you specifically. For all of our educators in Illinois, we're saying a special welcome to you as well. Thanks for being with us. Today is a PD session for our Illinois educators. That means that you will receive a certificate for 1 PD hour at the conclusion of today's webinar. Not only will you receive that certificate, but you'll be getting a copy of the slide deck for today and a link to the webinar presentation, a YouTube link. So that means that if you miss anything, if you have to jump off a little bit early, or you just want to go back and refer to what you saw for your own edification later on, you are more than free to do that as well. And of course, if you've got any questions, you will be able to contact myself or Segundi, and we will get right back to you. Mary, you're already in that chat. Really good. Yes. All of our participants today will be receiving their certificate for attendance. That's in our automated email. So we're going to make sure that you get that, Mary. So with that being said, we will press right forward. For those of you who have been in our webinars previously, welcome back. I'm really glad to have you. We hope that the information we shared is useful. For those who are new to NextWaveSTEM, welcome. Thank you for taking a little bit of your time to be with us and really help encourage your students when it comes to STEM. Without reading off the slide, NextWaveSTEM is a company that believes in our future and believes that the integral way to get to a future where children are becoming adults and professionals who are really well employed, but also solving some of our most pressing problems. In order for us to get there, they've got to get exposed to STEM really early on. That's why at NextWaveSTEM, we believe in developing curricula in emerging technologies for our students who are kindergarten through 12th grade. Not only do we develop that curricula, we license that curricula to our school partners. We train educators in that curricula so that you can go into the classroom and execute that curricula with fidelity and with confidence, and we're providing all the equipment that you need. It's something that we like to think of as our all-in-one package to get you out of the door with us and into the classroom, knocking it down with your students. We know that our students are extremely intelligent, extremely inventive, and have all kinds of ingenuity. And we want to unlock that potential, so that students from all over the country and all over the world can be prepared for a future that they don't know is coming. 5 months ago, well, even 6 months ago, we did not know that we would be in the place that we are right now with regards to a global pandemic. And even before a global pandemic, we still had issues of climate change and food insecurity that were causing and are continuing to cause huge problems in the world. Our students are going to need to be prepared to meet those challenges and solve those problems. So we at NextWaveSTEM are empowering you as teachers, so that future where we're solving problems becomes our reality. So with that being said, two things we want to cover in today's webinar, two really cool concepts. Something that we're doing in NextWaveSTEM and our distance learning offering right now is dealing with PPE. For those who aren't super familiar with that acronym, PPE stands for Personal Protective Equipment. Some of us might be really familiar with that acronym because of news coverage lately around getting people the materials that they need to stay safe during the course of this pandemic. We want to explore ways in which communities of professionals and even hobbyists are using 3D printing, 3D modeling to produce personal protective equipment. And then after we explore that, we want to set the groundwork for you as an instructor to begin that project with your students, even at distance. The amazing thing about working with an emerging technology like 3D printing is that it's just not the machine. There is so much work that comes before you ever print an object, and designing and considering who's going to use your object. It becomes a tremendous learning opportunity for our students. So we are going to explore some ways in which you can integrate that in your classroom. Some things that we're doing in our curricula right now that we would love to make available to you. So a really useful place for us to start is thinking about a distance learning instructional model. This is something that we've considered previously because it is important to recognize that as we teach emerging technologies, we've been away from the classroom, most of us, we've been away from the physical classroom with our students for months now. That has necessitated that we really consider effective ways to teach with new technology, using technology that our students might not have had access to previously, using technology in ways that we would not have previously used them. And not only are we using the new technology in terms of communication and interacting with our students, but we're using new technologies in ways that do physical work with our students. So we're exploring different learning modalities. In order to do that, we have to think about using an instructional model that actually works. So we want to first talk about where we start in an instructional model, considering that we want to teach computer-aided design, 3D printing, and specifically 3D printing for personal protective equipment. In our instructional model, it's actually really similar to what you might find in a traditional classroom setting, just adapted for the distance learning online digital modality. 5 steps to this instructional model, which we call the 5 E's. We engage. That means that we're setting a real world basis that our students can immerse themselves in, that they can see themselves in, and that they can relate to community members. The second thing we do is explore. We want to get into the nitty gritty. We're researching. We're learning more about how things actually work, whether that's the science or the math or the history of our subject. We are thinking through now how to explain. We're giving now students the opportunity to move up through Bloom's taxonomy, where they're just not taking in the information and remembering and being able to recall, but they're able to be critical thinkers and assess that information. So we're seeing that information now being synthesized a little bit and then brought back out from our students for us to be able to elaborate on and then evaluate. We're moving in a logical progression here for our students, just using a different tool. And when we think about producing something like personal protective equipment, I know I'm using that word a lot, and we're going to break down some more of what that means. Um, as we're getting to the point, we are going to learn very quickly that there are multiple steps and layers of understanding and skill building that our students need to acquire, not only with design, but with understanding how to use their computers and how to use a 3D printer. We have this really amazing opportunity to do education in a lot of different subject matter areas. So that's something that's really, really cool for me to see. So when we think about the progression, this is an example of how you might move through a particular class session. The introduction of that real world problem that we want our students to solve. Getting a chance to explore the problems with our actual whole group of students. If we've got our students who are tuning in with us into that classroom session, whether that's an hour or 90 minutes or 2 hours or however long, we have the opportunity for a dialogue via the group chat or even text chat. Some tools like Zoom, for example, allow students to break out into small rooms so we can assign groups and actually segment those groups. If that's what we want to see happen, we can drop in on our groups and monitor and actually moderate for our students as they're working. We give our students the chance to have the instruction explained. That's where you get to shine a little bit with your understanding of the technology. Our students can then independently work in that data synthesis. What have you explored? What do you now understand? And what have you built in terms of your skill following along with your instructor to then be able to build something yourself? And then there's that feedback portion where once the actual assessment task is done, once the actual work product is produced, it gets to come back to you as an instructor. This we found works really, really efficiently in the space for distance learning. Because it's not all on you and the students don't find themselves in situations where they're just watching their screens. The interaction is through the screen, but there are specific working points where they have to collaborate with their other students. They'll need to collaborate with you as an instructor, and then they'll actually need to use the technology. And so we're not just focused on one learning modality, we are hitting a couple of different modalities. That becomes really, really useful to not have our students be bored out of their minds, frankly. Now, the reason why I contrast and compare this with a project-based learning model is because we can see a synthesis of both the 5 E's and project-based learning. And once again, this is because of how powerful the layers of knowledge will have to be for our students to move from I might have not have ever done any kind of 3D design to actually generating a 3-dimensional object that serves a specific purpose. We have some complex ideas in design, in engineering, design process, and understanding materials because we might not want to make our PPE out of just anything. There's lots of research and student work that can be differentiated in some really exciting ways and can be student driven. These blocks that we see highlighted in blue become those decision points for our students in considering how they're going to get from point A to point B. That's something we'll dig into a little bit more and that we have talked about previously in our other webinars, but we're going to discuss a little bit more about how those work later on. So at this point, I'm going to slow down a little bit because I know I've said a whole lot here, and I want to open up and get your feedback here. We're considering specifically PPE, personal protective equipment, that our students might be able to design and print with their 3D printer. So I want some feedback from you. What are the kind of objects that you can imagine your students making that solves a real world problem using their 3D printer. Use your imagination. There's really not a wrong answer here, and we would love to dig into what your suggestions are just so that we can kind of ideate and get some thoughts flowing about how we might use this technology with our students. So I'm going to go silent a little bit as we let our minds work and our fingers work in the chat and the Q&A. And I would love to know more about what your students might make. Mary is on the quick trigger. Masks, face shields, goggles. Yes, yes, and yes. Those are objects that we can use our 3D printer to help us produce. And we're seeing a lot of that work. We'll get a chance to take a look at specifically what that looks like. Ooh, Segundi, very good. Ear guards. Ear guards, this is actually an interesting 3D printing development, really ingenious, as more and more of our population was using masks. They found that some of these masks did not fit really well and were actually causing ear strain with the way that they were actually being held to people's faces. An ear guard and a couple of different ideas for those designs have emerged to help mitigate that problem. So that was actually some really, really nifty, for lack of a better word, engineering that took place there. Is there anything else that we might imagine? These are really good answers, but I don't want to limit our answers because there's some things that might not appear to be completely obvious that are helpful as well. I'll just give it maybe another 15 seconds. Okay, this is an amazing start. Oh yeah, tighter pill caps. For our populations where having security for medication becomes really important, if we're working with small children, even some situations, pets, and we want to make sure that we're keeping medications safe and actually restricted from those who don't have them. 3D printing allows us to solve by making getting into those actual containers more difficult. Believe it or not, that's something that we might want to see from some particular um, medication containers. So that's actually a really good example as well. Great ideas, everybody. Uh, if I borrow them, I will make sure to give you credit the first time, just the first time. So when we engage in a real world problem, you guys had some really good suggestions. Our students are actually engaging and practicing citizen engineering. And the thing about our particular pandemic is that it's a respiratory issue, but we have some knock-on effects, and we have to think about holistically. If we're solving one problem, can we solve other problems? So one thing that we ideate for is thinking about lead filtration devices for homes. We know those who might face immunocompromised or be put in an immunocompromised position because of lead poisoning. That's something that can be mitigated if we can deploy some filtration services via 3D printing. Another way to think about this, of course, is directly the personal protective equipment, the things that we can put on our bodies to prevent this virus from entering our bodies. And we have some really great examples. We think about face masks and face shields, things like goggles, things that will keep the porous portions of our face mainly from having these viral agents enter them. And that is something that we're going to look at specifically once we get into our Tinkercad. Masks and respirators are also another way to think about this. Respirators will fall into two categories. Passive, letting air just travel in and out, of course, but then actually active, moving air that we know is clean into a breathing area versus air that we know might have an increased viral load. It's something that is more high risk for those who are treating patients on the very front line. That becomes really important to have. The third category, which is actually extremely low-hanging fruit, is what we think about as assistive touch devices. During the early days of the pandemic, what we have seen is people were really concerned about high traffic, high touch surfaces because of the way the virus is able to spread. One thing that helps with that is having a device that is not our physical body, does not uh, have the ability to either retain these viral loads or make sure that there is a barrier between our physical body and the viral load as well. Um, that's something that we're actually going to take a look at first, is a way to interact with the world around us that doesn't require me to actually physically touch the world around me. So that's going to be really cool to look at. Um, so like I mentioned before in this PBL model, because we have these different categories of things that we can make. We can make the assistive touch device, we can make the face mask or goggle, we can make the respirator. We now have these multi-layered opportunities for our students to drive their work. Um, and each class session, as our students are exploring and engaging and are collaborating with each other and you as an educator, um, whether they're working together in groups or working together individually, we can really assess where they're at in the design process and make recommendations or let our students completely self-drive what the next work is going to be. Maybe their first point of activity for them as students, their first deliverable to you is research. Kind of doing what we just did and going through the literature, reading the news stories, going on the hobbyist boards, and learning more and more about the physical items that help stop the transmission of the virus. Um, and as they make that forward and differentiate between those categories, they're having individual discussions about those categories. They're reading more specifically about individualized assistive touch devices or how an ear strap works in geometry. And then they're getting more specific and individualized as they're creating their designs, preparing their prints, mocking up multiple and different prototypes. It becomes something that you as a teacher have to benchmark and assess with regards to their learning growth, but something that also becomes really individualized for your student, and something that has the potential to actually work and be used in the real world. Um, so the project-based learning model can go down many different paths with regards to student work, but still has this outcome of not only producing the solution, the thing that we want someone to use that makes their life better. It just doesn't do that, but it gives you the consistent ability now to benchmark your students' growth in their learning and to help them as they reflect in thinking about what the next step should be. So lots of information, lots of really good stuff there. Amazing stuff. We want to get to nitty gritty. If my student is designing a piece of PPE, what does that process actually look like? And we'll go and take a look at a really basic example when we think about an assistive touch device. And then we'll take a look at the different capabilities that will allow your students to iterate on some other devices. Or if they're just interested in doing some good and you've got a 3D printer, getting those devices from being a spool, a filament, to being something in someone's hands right now. So we're at the launch. We're at the very beginning. The important thing here is to establish for our students this context that the 3D printer, the CAD, in this case Tinkercad that we'll be using, is the tool that they'll use to be able to solve the problem for someone else. So at this point, I'm actually going to change up my screen share. And in changing my screen share, we're going to go straight into Tinkercad. Now, Tinkercad, for those who have been with us again, is free cloud-based computer-aided design software. It has the really tight benefit, the really robust capabilities that we want with respect to being able to make really complex shapes because we're using both additive and subtractive properties. If I pull out a shape like a box, that we see on the screen, I've got this actual, it's a cube actually, and I zoom into this cube. What I'm able to do is click on any of these touch points in the corners or in the middle of a line segment, and I can adjust the size of this box accordingly. I can, and I'll zoom out for this. I can float that box up and down in the air. I can rotate this box along all three physical axes so we can see how that changes a little bit. And then in the upper left-hand corner, I have what's called a view cube. This view cube allows me to change my personal perspective on the box. And in changing my personal perspective on the box, that allows me to make sure that things are scaled up. I'm not getting something that's completely wonky and completely non-usable. So let's talk about an assistive touch device. We're going to go from order of least complexity to more complexity. We'll start with an assistive touch device, and then we're going to move up to a face mask, and we're going to show with the assistive touch device the ability to design an object that's easy to print for your students, and then this ability to actually do some research and modify other objects that allow us to do some good work. Now, a personal assistive touch device is simply any device that works as an extension of my own hand. And it's an extension of my own hand because I want one part of that device to be touching my hand, and I want the other part of the device to be touching the surface. A really, really crude way to think about it is that once upon a time we had privateers who were working on the high seas, and sometimes they would be injured doing pirate activities. And when they did those pirate activities, they would need to have prostheses, things like artificial hands, things like hooks, things like forks on those hands. Those in a way became assistive touch devices. If they, for whatever reason, lost functionality of that appendage, they would need to have something artificial that would give that functionality back. And we see that even today, especially in the 3D printing space, where prostheses have become much more advanced and much more functional, and now we can 3D print those prostheses. We can think of those as artificial extensions of our own human bodies. With respect to a prostheses, is something that was lost, and within an assistive touch device, nothing is lost. We're just extending our capabilities specifically so that we can distance ourselves from material that might make us ill. So we say to ourselves, okay, what's an example of an extension of our body? Well, really, we can think of that as simply a tool, something that's hammer shaped, something that's shaped like a ruler, something that's shaped like a fork or a spoon, because those are tools. Even something that's shaped like a key, because a key is a mechanical tool. It fits inside of another mechanical mechanism, and then using torque and force allows us to open a door. Those physical items are actually can be considered as extensions of our bodies, usually extensions in one direction. So we can think of our most basic idea of an assistive touch device in that same way, something that extends our ability to reach towards an object. So let's start with the basic design. If we want to extend our ability to reach towards an object, say the same way we would with a fork or a ruler, there are some commonalities in those designs. The first is that they are small enough to fit inside the grip of your hand. The second is that they are usually long. They're thin. The ratio to their length and their width is pretty high. So what I'm going to do with this box is I'm actually going to modify it. These numbers that we see listed in our box are in millimeters. The reason why they're in millimeters is one, the decimal system is really effective for us to do math with. It allows us to change scale and dimension really, really easily. So I'm a big advocate of the metric system and teaching our students metric system, even when we live in countries with imperial units. The second thing is that 3D printers use the metric system. They're precise, they're base 10. Mathematics around metric is really easy to define. And when the 3D printer is printing, it's printing in really, really precise increments, usually in fractions of a millimeter. That's really much easier to be done with metric. So if I remember, or if we remember our conversions from high school, just that quick conversion from imperial to metric, we know that 1 inch is equal to about 25 millimeters. It's 25.4 millimeters. And that means that we can really, really easily use a basic unit of measurement. This distance between my fingertip and my knuckle is about 1 inch. I can put in this case, 25, and get an object that I know is already about 1 inch high. And in that same way, I can now start to extend out. And if I know that 25 is 1 inch, at this point, this square is 1 inch by about 1 inch, 1 inch long by 1 inch high. Maybe I now can think about how big of this design I want it to be. If I want it to be 5 inches long, which seems like a pretty reasonable extension away from my hand holding it, or maybe 4 inches long if I've got 1 inch grasp in my hand, I would just pull this out, or I could just simply do some quick multiplication. Call that 125, and now I've got a much longer object. So this object is now 1 inch high, 5 inches long, and less than half an inch thick. This is a good place to start for a personal assistive device. We've got about a 5-inch ruler space pulled out for us to think about. Now we think about functionality. Will my hand be able to grasp it? If my hand can grasp it, what can I do with it? Which part of this am I going to touch? It becomes really useful for us now to define some of the different parameters that we want, some of the design elements that we want. So I'm going to make a distinction between the two ends of this tool. I'm going to pull out the cylinder. I'm actually going to rotate the cylinder over because I'm going to punch a hole into the end of this tool. I think this is really useful because if I want to put a king ring on the end of the tool, I can. If I want to put my finger through the end of the tool so I don't drop the tool, I can. Putting a hole in the tool sometimes can be really, really useful. So in order to do that, I've got a cylinder that is here. I'm going to take the cylinder. I'm going to find the appropriate axis. And I'm going to rotate the cylinder just 90 degrees on its side. So now that my cylinder is rotated on its side, that's really useful. I'm going to pull the cylinder up in the air a little bit. So I've got some distance from the working surface and my cylinder. And now I'm going to enmesh. I'm going to make my two objects collide together. So I'm going to move the cylinder in such a way, which is actually pointing through. I'm going to zoom in on that cylinder some more. I'm going to move this so that it's now sticking through my my actual short for the purposes here, my short ruler. Fine, great, good, except that I've got a solid cylinder and I've got a long pointer. That's not a hole, right? Well, all I have to do now is select on the cylinder, and in my shape inspector, I have some options. I can make this cylinder have more bevels so that it's a smoother cylinder, this geometrical representation. I can adjust the number of segments once again to increase the fidelity with which we're getting this circular figure. I can change something called the bevel so that I can take the cylinder and round it out. All that is fine and good. But what I care about is creating this positive space and making it a negative space. So when I click on this option that says hole, my cylinder, I'm going to zoom into it, now takes on the property of having these lines, these grayed out lines, which means that it's now a hollow cylinder. So I've got this negative space, I've got this positive space. If I add a negative number with a positive number, the result is going to be something that's smaller than that positive number used to be. That means that I will select both objects. I'm going to drag my cursor over both, just like highlighting in Microsoft Word, and I'm going to group them. So now that I've grouped, I've actually taken that negative space and cut the negative space away from the positive space on my pointer. I've got an object that I can now put a finger in and now manipulate and control. Now the question becomes on the other end, okay, what's a useful thing that the other end of this object can do? I've just got a pointer. Right now I can only poke at things and make some things happen. But if I'm maneuvering through my everyday world, what's something that might be useful for me to be able to do with this object? And we've got some different options here. But the most easy thing, I'll go back to that pirate metaphor. I found a really interesting video on YouTube yesterday about pirates and how to be a pirate. And in large part, it's about marketing, but that's another conversation. The reason why hooks are useful is because they give us the ability to actually interact with an object by applying force. We're not going to get any slippage from a hook. This is my crude hook here. So if I've got a doorknob that's a bar, I can put a hook on the end of the doorknob and turn that bar. The hook is also useful because the hook will allow me to manipulate soft objects, things like straps, things like handles for the end of a book bag, things like plastic grocery bags can go on the end of a hook. Things like my car door can also be hooked and pulled. The hook gives the ability to push and pull as well. Mary just chimed in there. Absolutely right. We can manipulate things that are rigid, like brooms. If I can get the broom inside the radius of the hook, strap handles, that becomes really, really useful. And so in this way, the assistive touch device isn't just about keeping us safe from COVID, it becomes an accessibility feature as well. So if I want to design a hook, there are a couple of different ways to go about it, but I know I'm going to need some kind of radius, some kind of curve in this hook. And to develop that curve, I'm actually, instead of using a cylinder, going to use a sphere. So now I've got a sphere that's pulled out here. I'm going to orient the sphere in such a way where I want to adjust the way the sphere, once again, interacts with the end of my pointer, the other end. So I'm actually going to select them both so I can see them a little bit better. Zoom in. I'm going to rotate my view around. The sphere, there are a couple of different ways I can go about interacting with the sphere. The first thing I'm going to do is actually enlarge the size. I think it's a little bit too small. So we're going to bump it up by 50%. I'm going to change 30 for the width and 30 for the depth, and then another 30 for the height. So our sphere is 50% bigger than what it used to be. And I'm already just now going to change this to be in a hole. That's going to allow me to visualize a little bit better the way my sphere is going to end up interacting with my pointer. So I'm going to maneuver the sphere over this way in such a way where, as far as I can tell, and we could be more precise, but the midline of my sphere is just about in the midline of my pointing device. That's good. And now it's the issue of where to cut the curve in my sphere. So I'm going to move that inspector. I'm actually going to take my sphere and I'm going to change its height. So grabbing on this arrow, I should say, I'm going to pull the sphere lower into space here. And at this point, I really have free reign over the way I want the curve on the end of this tool. So I'm going to adjust its positioning ever so slightly. And I'll actually drop it right here. I can actually adjust this figure a little bit more because now I'm thinking about how big I want my curve to be, the actual contours of the curve. And I think that's where I want to be for right now. So I was rotating around. You'll actually see I have a little bit of difference in the curvature on one side and the curvature on the other side because of the way that I've actually drawn out the figure. This may be a good thing depending on whether or not you're going to have a smaller radius object we're going to work on with one side or a bigger one on the other side. So this can be an intentional design feature. It isn't for this webinar because we are just giving an example, but something that you can work on with your students is building in that consideration when you think about who's going to use your object. So I've got a solid object. I've got an object that's a whole. I'm going to select them both and group them. And I cut out another space. So now I actually have developed and designed this assistive touch device that is basically a pointer with a hook. You've got a place to insert a finger down on this end that allows for better control, that allows for me to hold this or put this on a key ring. On this end, we have a hook, something that allows me to apply force or capture a strap or another soft-bodied object to manipulate. And it gives us distance between the hand, which will be down here near the hole, and the object, which may have some kind of viral load. This is a really basic example, but something that's quick for your students to mock up, and that can be quickly modified as well, considering what their needs are going to be or the need for the intended user. And the whole point is to show that this is only 3 shapes that are put together here, but the chance to iterate and change these shapes into really, really useful figures, things that are more comfortable or are better, are easier to use for people with different hand strengths, for example. All this learning begins to as we iterate on this design. So this is one really simple way to design for PPE, something that we actually teach our students how to do in our PPE course. So to transition a little bit and change things up, that's one low-hanging fruit. The second thing that you can do as an educator is really encourage your students to dig into online, especially hobbyist resources. Forums like Thingiverse, which have free STL files for you to download, become really, really powerful. So you see here, they've been doing a Hack the Pandemic initiative. Their whole purpose is 3D printed designs specifically to keep people from getting sick. So things like nose guards, those mask adapters, things like 3D printing parts for masks, or even experimenting with face shields. Something like we showed today, the No Touch Challenge, which is the assisted touch devices, becomes really easy to use. In this case, I would actually take a look at one of these devices, the safety key for protection. goes to our point again about the way that we can design an object. Uh, with our safety key, it's a flat object, has a hole in it for us to be able to control, and has this hook-like appendage at the end, but also the ability to have a pointer to push buttons, for example, say on an elevator. Really, really simple design that allows us some powerful tools. From Thingiverse, I can actually select the thing file. In this case, this STL, that's called COVID key. I'm going to download, and just like we can import and download an essay, a text file, or a PowerPoint file, I can download an STL file, and I can upload that STL, the 3D printing file, into Tinkercad for me to be able to modify. So I'm going to choose a file. You won't see my file window, but I'm going to grab the COVID key. We'll see that it's going to pop up right here. And it even gives me some parameters. It's got a length of 7.5 millimeters, a width of 45 millimeters, and a height of 120 millimeters. So this object is also about 5 inches long. We'll import. And I'm going to select this object so we can get a better look. And there it is. This is certainly something that one of your students would be able to design, but this can also serve as inspiration if we need to modify for a specific population. So this object, and I'm going to rotate it down. This object is about 5 inches long. Well, let's say I wanted something maybe 7 inches long. I can modify the length. So instead of being 120 centimeters, I might make it 170 centimeters. Now I've got a longer touch device. And this circle here, because everything's scaled out, is now an oval. That may or may not be a good thing. That might allow us to put multiple fingers in there to give us more control. This becomes something that our students can modify. So we've got two modalities there. We can grab and we can modify. These are just examples. And we can design from scratch or we can modify. Simply examples for us to go, but there's all kinds of resources for giving your students things that they can do that will make real world impacts. I'm going to accelerate because I know our time is drawing down really quickly and go back to our presentation. So at this point, I know we've shared a whole lot of information. Don't worry, we're going to make sure that this recording becomes available to you. We want to talk specifically about how NextWaveSTEM can help you in your schools. We've shown you some schools, some cool things, some useful things. I want to turn it over to Segundi now so she can talk a little bit more specifically about what NextWaveSTEM is doing and how we can partner with your school to help you a little bit more.
Awesome. Thanks, Desmond. So yes, as Desmond has been talking about, all of the stuff that we do is extremely hands-on. And so what we've done moving forward and kind of to address everything, in addition to all of these trainings that Desmond has done, which I'm seeing a lot of familiar names. So maybe this is maybe the third or fourth time you're hearing the spiel. I'm going to give it anyway, you know, just so it's out there. Desmond's going to continue to have these PD sessions. So please continue to join us. We love having y'all here with us. And if you can go to the next slide for me, Des, that would be awesome. Our offerings are, they continue to grow. So we have different ways in which we interact with students now. One is the online experience. So what we've done is we've taken our classroom materials, our classroom instruction, and just kind of put it into more of an online platform. And our whole approach is to make everything hands-on. So even if the students are in front of a computer, they're going to be following along with the instructor and using Tinkercad, using other applications that are freely available to do some really hands-on design, to think through things, to iterate just the way Desmond was iterating with the keyhole. And so we bring them through an hour-long class process. We actually have a specific class dedicated to designing PPE, where we walk students through a 5 or 6 lesson sequence. And by the end of it, they have some interactive, and we've got great feedback from students about that too. Our hands-on experience class, which is the offering on the left of this slide, is where we have those classes, but we also have kits, STEM kits that are delivered to the students. So they will get a drone, a robot, 3D printer access, and they'll be able to bring those things to life. You know, both ways are really great ways for kids to stay involved. And we know that with summer coming up, we want to make sure kids don't experience that summer slide as intently as they might have in the past. So we want to make sure that their learning is continued, that they're engaged, that they have something, you know, really solid hands-on and academic to do even during the summer. Thank you, Desmond.
Thanks so much, Sugandhi. Really appreciate you sharing a little bit more about the hands-on courses that we have available for students. The PPE course that we're doing, distance learning, for your students, teach them how to design PPE elements, becomes something that's really, really powerful. And we are also really focused at NextWaveSTEM that understanding we don't know what the future is going to be. That you may be in your classroom with your students in the fall. Their expectations certainly around our ability to continue to keep people safe and educate our children in person with really effective education. That means that what we do at NextWaveSTEM is adaptable. We're designing specifically in mind so that if you're remote, your courses will work that way. But that if you are continuing to be at distance, we'll be able to support you with the equipment and the training that you need to deliver your courses at distance as well. So we're just really hoping to continuing to be a resource for you. So lots of information. Time is running short, definitely, but we want to make sure to leave enough time towards the end of our webinar so that you could ask any questions. So if you do happen to have any questions about designing for PPE or about what we're offering at NextWaveSTEM, we want to give you some time to ask those now. So I'll pause. I'll take another sip of water while those fingers are going, while those brains are going, and we'll answer any questions that you have. Okay, I don't think we have, oh, there we go. On the road with ATP and BSE, could you use me? I intend on carrying 3D printer, laser cut, and Fusion 360 in fall. Would teach third world ministries. You know, Mary, we would love to talk with you a little bit more with regards to 3D printing and laser cutting and Fusion 360, because you seem to have like a really specific situation that you're working in. And we would love to chat a little bit more. We're going to reach out to you to figure out more how you're looking to use those 3D printers, especially in international contexts. It's really, really cool. Yeah, we're gonna shoot you a message, Mary. Okay, I thought it says work with Scardy. Also blind person in my cohort. Yeah, this discussion, and I'm glad that you're bringing it up. While we're talking about personal protective equipment, specifically in the context of our webinar today, a lot of what we focused on will also work with respect to disabled and also assistive, adaptive, able communities as well. Accessibility applications are huge, 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 huge when we think about 3D design. Even the tools in which we do 3D design, we're having challenges with accessibility. So this ability now to really help navigate those issues by constructing devices, really powerful engineering learning, but just doing good. We want to empower our students to think diversely about the world that's around them and the people in it, 3D design is a great way to be doing that. So designs for carts, mobility, adaptability, that becomes huge, huge, huge 3D. We would love to chat more about that, Mary, as we consider all those perspectives. Really good comment there. Are there any other questions or comments? I'll just give like another 15 seconds or so. Mary, you're not the only one, but you are our very loquacious one today. So we're really thankful for having you on with us. We've got a couple other participants with us, and we're glad for all of you. So thanks for joining us. Well, for all of us who are on the line, I want to encourage you that if you have any questions, we would love to hear from you. Reach out to us. We don't mind emails at all. My email is up on the screen in the upper right corner of your screen. I believe you'll see my face in color. In the middle of the presentation, that's my face in black and white. You can reach out to me by email, really, really easy. It's desmond@nextwavestem.com. My colleague Segundi, her email is also really easy, segundi@nextwavestem.com. I'm thinking Segundi is going to drop her email in the chat for you as well so that you can reach out to her if you've got questions about school partnerships. We are on Twitter, we are on LinkedIn, we are on Instagram, and we're on Facebook. You can check out the work that we're doing there as well. And spread the word with your colleagues and your coworkers. More than anything, we want to make sure that students of all backgrounds can have the opportunity to learn about emergent technologies. And we believe that you as educators are in the prime position to help make that future a reality. Before I go, I also want to remind everyone that you will be receiving the follow-up email today with the slide deck and with the certificate for attendance for the webinar, as well as the link to view the recording. But we do have another webinar coming up as well. Tuesday, June 16th, we will be having our webinar, Making Drones Real, while we're interacting with physical objects. For those of you who are interested in keeping your students engaged with computer science, learning about robotics, in this case, flying robots, which is what a drone is, and how they can learn from a distance, but if they get a physical drone, interact with the objects that they have around them or in your school, that's going to be a really exciting webinar. So we hope to see you on that webinar next Tuesday. Until then, we're hoping that everyone is staying safe, staying healthy. We're hoping that you're staying engaged with your students as well. We know that they miss you and that you miss them terribly, but we are all going to get through this together. Until we see you again, thanks so much for joining us, and we will speaking with you all of you very soon. Bye-bye now.